Okay, welcome back, and hope everybody had a good weekend. Staying cool. All right, so there's just a reminder. There's a few assignments due today, or a few homework assignments, and so everyone got their the first homework assignment in the chapter one and two homework. This one, and like I sent you guys an email, and I put up some grades for those. So you should see your grades on Blackboard for that first assignment, and then these two due today. So I think most students have turned those in, but I think there's let someone in here. I think there's still a few that need to be turned in. Yeah, so the homework chapter 3 and the elasticity homework, make sure those get turned in today, due by the end of today. And so, yeah, it looks like any questions on those assignments just before we move on to new material. So everyone good on turning in those two assignments today? Okay. All right. So yeah, just get those few students get your homework for chapter 3 and your elasticity homework turned in today. All right. Okay. So what I'd like to do today is the next item on the syllabus, which is chapter 4. And so we're going to talk about it's called the theory of individual behavior. We're going to look at some how individual consumers make choices, and it's a pretty simple model. You might have learned some of this in any introductory econ course, but it's somewhat relevant to some of the things going on today. So I'll try to tie it into some real world examples. But okay, all right. And I think today's meeting will be a little, I mean, around 2 hours or so, or a little bit less. And so I'll try not to go over, even though I did the first two meetings. But I knew that meeting two would be a little bit longer, and meeting one I had to get some of the introductory stuff out of the way. But we only got the chapter 4 to do today, and so we'll try to keep it under 2 hours. But if not, I'll do what I can. All right. And again, yeah, and so we are because the holiday on July 5th. I did have to combine some of the material into other meetings, and so that's why uh, maybe if some of the meetings are a little bit longer, that's because I had to eliminate one of the meetings due to the holiday. But so we got today's meeting, we got next Monday's meeting, and then we have 2 weeks off because the holiday falls on that July 5th, and so we'll have a couple weeks off and won't meet again until July 12th. Okay, so let's go ahead and start chapter 4. All right, so you can open up the chapter 4 document here under chapter 4 in Blackboard, and you can open up the homework chapter 4. We'll get to those things a little bit later. And you can open up under PowerPoint, the chapter 4 PowerPoint, and I'm going to be looking at some of the older 7th edition of the textbook so I can show you some graphs. All right, so let's go ahead and let's jump into chapter 4. So this is the theory of individual behavior, and it's going to show how simple models of how consumers decide between multiple goods if when you have prices and budgets and income, and what happens if those things change, and how you can kind of get this. This leads into the uh, graphical derivation of the demand curve, I guess. All right. So first thing is let's just introduce indifference curve. You might have seen this concept before, but what it does is it kind of shows how an individual consumer makes choices that give that consumer the same level of satisfaction or happiness or utility. So if you look at figure 4.1, all right, so this is an indifference curve. So what this shows, figure 4.1 here, is there's two goods, all right, good Y and good X. So these are the units some consumer consumes of good X along the X-axis, and these are the units that some consumer consumes along the Y-axis, right? And you can see that this red line represents an indifference curve. And on the indifference curve, the idea is that any point on that curve, the consumer is indifferent between. So like point A and point B and point C all represent the same happiness or satisfaction for the consumer. Like the consumer would be happy with, in this example, uh, six six Ys and one X, or four Ys and two X's, or three Ys and three X's. So any point there on that curve or any other points in this curve give the consumer the same level of satisfaction. Now, if the consumer gets to a higher indifference curve, they're happier, or if they get to or if they drop down to a lower one, they're worse off. But on the same indifference curve, they're indifferent. Okay, so and you can see kind of if the consumer is going to give up the we see the simple concept of opportunity cost here, right? So if you give up some of one good, you got to get back some of the other. So the consumer would be willing to keep the same level of happiness if they're at point A. So if they're going to get one X, they'd be willing to give up two Ys. All right. So that rate of trade-off there is something we call the marginal rate of substitution, and this is simply defined here, the rate at which a consumer is willing to substitute one good for another and still maintain the same level of satisfaction. So any trade-off or any um, transition, or I guess the slope of this curve would represent the MRS, because the rate at which the consumer wants to get more of one good uh, is equivalent to what they give up from the other good. So you can see that that point changes, and see how the curve kind of gets steeper or flatter. It gets less pronounced as you get to the extremes. And that's because if you have a lot of one good, like if you're one-sided, if you have a ton of Y but little X, you're willing to give up a lot of that Y to get some X, and vice versa. If you have a lot of X and no Y, you're willing to give up a lot of X to get some Y. So if you have too much of one good, you'd give up more of that to get just some of the other, and kind of have a more of a balanced bundle depending on the goods or services. But the idea is if you're somewhere in the middle, your rate of trade-off is more close to um, equal. And if you have extremes, like if you have a ton of X and no Y down here towards the bottom part of this six or so, then you're willing to give up a bunch of X to get some Y. So that's why the slope kind of changes, because the rate of trade-off changes for a consumer. Okay, now so that's the concept of indifference curves, and we're going to talk about these a lot more. But let's now introduce something called budget constraints. And budget constraints are what constrains the consumer from buying more of the two goods. So, all right, so let's budget line or budget constraint is kind of the same thing. And so this definition here, the budget line, is the bundles of goods that exhaust the consumer's income. So in this example, we only have two goods, good X and good Y. So the consumer has an income or a budget in which the consumer can spend all that budget on either good X or good Y, or both. So M here is income, PX is the price of good X. X is how much good X the consumer buys. PY is the price of good Y, and Y is how much good Y the consumer buys. So you can see that if if we're assuming this the consumer essentially exhausts his or her budget um, on these two goods, then they can either spend it on good X, they can either spend it on good Y, or they can probably most likely spend it on both things. So whatever they spend on good X times the price of good X, like if you buy this many X's and that's the price, plus whatever you spend on good Y, like that's how many Y's and that's the price, then if you add those together, that's how much income you have to spend. So you're constrained by the prices of the goods and your income, right? So this is your budget line saying that the price of good X times what you buy of good X plus the price of good Y times what you buy of good Y has to equal your income, because in this simple example, you want to use your income, you want to exhaust your income because that'll get you to the highest level of satisfaction. Okay, and you can graph this in, sorry, budget line on the same picture or graph as the indifference curve, right? So the indifference curve was up here. We had the y-axis was y, good y, and the x-axis was good x. Okay, so this is how much you buy of y going across the top, and this is how much you buy of x going across the bottom. So we can put the same budget line on this same xy plane, right? So here's the budget line we just talked about. Now, if we want to put this on the xy plane, we need to solve it for in terms of y, and then we can plot it for like y as a function of everything else. So just take this one here, and let's go ahead and divide both sides by py. Okay, if you do that, we get this. Okay, and then let's go ahead and add or subtract px divided by px divided by py times x to both sides, and that gives us this. So basically, all we're doing is starting with this and solve for y as a function of everything else. We get this. Y equals m divided by py minus px divided by py times x. Okay, and then if we get this, we can graph it simply on the same axes or the same graph. So you can see that if this is the same function, this is our budget line where y is a function of everything else. Okay, you can easily get your put your line in and get your intercepts, right? So if basically, let's say x is 0, right? If there's no x, then your graph starts at the point when m divided by py. So that's why just plug in 0 for x, right? And that's why you get this point, okay? If you did the same thing, basically you solve for x, you would get that x equals m over px minus py over px, okay? And so if you did it the other way and solve for x, you would get this intercept. And so basically all I'm saying is to graph it, start with this simple budget line, pxx plus pyy equals m, right? And then let's assume that first x is 0. When x is 0, you find what y is, all right? That's this intercept. And then go ahead and do the same exercise. Let's see what when y is 0, okay? And if you find the intercept, you'll get this one. So basically, if you do a little algebra, you'll see that your intercepts are determined by your income and the price of the good, okay? So see this for y, all we have here is income divided by the price of y. So that means if income goes up, we can buy more y. Or if the price of y goes down, we can also buy more y. Now, if any of those things go the opposite direction, you get less income, or the price of y goes up, you get less y. So the only things that affect how much of the good you buy are your income, your budget, and the price of those goods. So it's very simple where how much y you buy depends on how much on your budget and the price of Y, and how much X you buy depends on what your income is and the price of X. And if anything changes, that affects your consumption choice. Okay, so this line here is the budget line where Y is a function of everything else, and there it is. So then you can take the budget line part and the indifference curve part and put them together. Actually, first let's define this. So something's called the market rate of substitution, which just depends on the prices of the goods. So the market rate of substitution is the rate at which one good may be traded for another in the market, and it's essentially the slope of the budget line. So the market rate of substitution is just essentially the ratio of the prices. So how much you can get of one good, um, like when you want to buy more Y, you got to give up some X, and when you want to buy more X, you got to give up some Y. But the trade-off opportunities depend on the prices. So you can see that your budget changes if the prices change. And so the slope of this curve is just the ratio of the prices. So see this? Negative px over py. That's the slope of this linear budget line. And you can see that if the price of good X goes up, that's going to make this steeper, which means you're going to buy less X because it's now more expensive. Or if the price of Y goes up, it's going to get flatter, which means you're going to buy less Y because Y got more expensive. Okay, so the slope of this linear curve is directly determined by that marginal rate of the market rate of substitution, which is just simply the ratio of the prices. Okay, and so we got good Y on the Y-axis. We got good X. Let me make sure nobody's. Okay, so we've got good Y on the Y-axis, good X on the X-axis. We have indifference curves which show the consumption bundles in which the consumer is indifferent by consuming different amounts of X and Y. And we have a budget constraint which tells us how much we can consume in total based on our income and the prices. Now let's put both of those things on the same graph. Okay, here it is. So this is simply defined as consumer equilibrium. And so this is the equilibrium consumption bundle, is the affordable bundle that yields the greatest satisfaction to the consumer. So this is, given their budget and the prices of the goods, this would show the best they can do and to get the highest um, satisfaction, or another word is utility. If you've heard utility, that's like economic talk for satisfaction. But see this figure here? So if you're going like this, so if you start at 0 and go outward, then the consumer gets the highest utility by getting to the highest um, uh, indifference curve possible, like going from like this way. All right. So you can see that there's all kinds of different points the consumer can achieve. Um, the options listed here are point A, point B, point C, and point D. Now you can do the exercise, but you can see that point A is fine. Point B is better because it's on a higher indifference curve. Point C is even better. Now, point C is the um, equilibrium choice because it represents like the boundary point or the tangent point of the budget line and the highest indifference curve possible. So see how if you start with C and do the exercise saying like anything below C, the consumer's worse off because they could possibly get, they're not using their budget line. They can get to a higher difference curve, right? So if they go down to point B or anything below C, right, they're not doing the best they could because they can possibly get to point C. Now, point D or anything beyond point C isn't achievable because their budget doesn't allow that. So you can see that the tangent point where the kind of indifference curve just touches the budget line is always going to be the best point because that's the point at which the consumer gets the highest utility possible and uses all their budget. Any point beyond that isn't possible. Any point below that going this way is they're worse off. All right, so see that? So kind of look at, you kind of start with your budget line and then you kind of get to the, you go out until you get to the highest indifference curve possible, and that you want the, you could, in theory, the best one is the one that just kind of tangents or hits the budget line like this. See? Like that. Yeah. Okay, so the next thing we're going to do is we're going to look at, so we've defined indifference curves, we've defined budget lines, we've defined equilibrium, which is the highest indifference curve you can get to given your budget line. But now what if the fun stuff is what if something changes? So what if income changes or what if prices change? That's there's all kinds of different um, comparative analysis, or I guess it's called comparative statics, which is just like, things changing, or analytics. When something changes, what happens to the consumer's new choice? All right, so everyone good so far? Everybody following along with the concepts here? All right. Okay. So let's start looking at what happens to the consumer's choice if something changes, and then we'll go ahead and think of some examples here. So let's. All right, so there's a whole bunch of different things you can look at, but first, so we're going to look at like an initial point, and then something changes, and then what happens to the consumer's new choice. So this one shows um, there's a decrease in the price of good X, and also the caveat is that good X. Hold on, let me let somebody into the. Okay, so here, good Y is a substitute for good X, so the goods are substitutes, and there's going to be a decrease in the price of good X. So let's go ahead and, all right, so our substitutes were, let's say this is, all right, so simple substitutes, classic example. I don't know if anybody even drinks Coke and Pepsi anymore, but that's the kind of the go-to for a substitute. So let's say the good X is Coca-Cola and good Y is Pepsi. All right, so we're starting at point A, right? So this is the consumer's initial budget line, the black one, and this is the initial indifference curve, Roman numeral I, and we're starting at point A, where the consumer is consuming this much Pepsi and this much Coca-Cola. Okay, then what happens is we have um, there's a decrease in the price of good X, so the price of Coca-Cola goes down. Now, what happens is that if the price of Coke goes down and these goods are substitutes, the consumer is going to buy more Coke and less Pepsi, right? So you can see that here. So when the so look at the change. So nothing happens to the price of good Y, but the price of good X, which is Coca-Cola, gets cheaper. If the price of good X, so see this, PX 0, if that drops, okay, this whole number gets bigger because the same number divided by a smaller number is bigger. So if the price of good X goes down, this intercept shifts out because now this number is higher. So given the same income, with a lower price, you can buy more. You can buy more Coke, right? So this shifts out here, and then you can see that we move to this higher indifference curve, indifference curve 2, where see how the budget line kind of kinks out, goes from this to this, and that's because the only thing that changed is this um, price of good X. It got lower, so this intercept changes, but this one doesn't change because the price of good Y is the same. But when it kinks out, that means we can essentially buy more X, and we do that. So the consumer buys the new point B, where we're tangent to the higher uh, budget line with the highest indifference curve, and that represents the point when the consumer buys a little bit less Y and a lot more X because uh, Coke got cheaper. So the consumer is buying a lot more Coke and less Pepsi because the relative price of Coke is now cheaper than Pepsi, or than it was before. Right? Okay, next example is complements. So remember we talked about complements in the last couple chapters. But let's say that what are our complements? How about milk and cereal? All right, so we have complements. Simple complement example. Let's say the good X is milk and good Y is cereal. So the consumer needs to consume these two goods together, especially cereal, because it's very rare that you see consumers um, consume cereal without some form of milk. Okay. Um, all right. So good X in this example for complements is milk and good Y is cereal. Now what happens? We're starting here at point A. We're consuming this much cereal. Okay, and this much milk. Okay, initially at point A. This is our initial equilibrium where we're on this budget line and we're at this utility curve. Okay, now what happens is the price of milk falls. Price of milk falls. Okay, this intercept changes, this goes down, so this whole number shifts out because we can buy more milk with the same income and everything else. So this kinks out here. But you can see that because we need to consume these two goods together, we're not going to consume less Y than before because these goods are complements. What happens is the new point B, we consume a little more Y and a lot more X because X is cheaper. So see the difference here? This one, the price of Coke went down, and we buy the new equilibrium is we buy less Pepsi and a lot more Coke. This one, they're complements. So the new equilibrium, when the price of one of the goods goes down, in this case, milk, is we buy a little more um, cereal and a lot more milk. All right, so see the clear difference where you can use this little example to show the changes for complements and for substitutes. All right. Okay, next one. This is income changes. So now we looked at the prices changing. What about income changing? Okay. All right. So let's say that these are normal. So normal goods, and income is going to change. All right. So doesn't really matter what the good is, but let's say that let's okay. So how about that? Good X is toilet paper, and good Y is chicken. So we're defining both as normal goods, meaning that if you get more, if you're spending your money on both of these things, and if you get more money, you buy more of it. If you lose income, you buy less of it. All right. So okay. So this is good Y. So this is how much chicken we buy, and this is how much toilet paper we buy. So we start here at A. We have the prices are PY and PX and PY, and this is the initial income. Now the prices aren't going to change. So the slope of the curve or the ratio of the trade-off isn't going to change. But if we get an increase in income, see what happens. This number gets bigger, so this shifts out, and this number gets bigger, so this shifts out. So we essentially shift out this way, but it's the same, like it's the same slope as before. So see how this distance is the same, it just kind of shifts out there. And for two normal goods, so in this case TP and chicken, we get more income. The idea is that we're pretty much going to spend the same amount on, well, I mean, we're going to spend more, but the ratio is going to be about the same because the prices didn't change. So the prices didn't change, and instead we buy relatively more chicken and relatively more toilet paper. But the price ratio didn't change. We just buy more of both. All right, we go from A to B. See that? Okay. All right. This one's a little weird because it represents one of the good being inferior. So let's think of an example here. Let's say that we need good X to be an inferior good. All right, so we'll stick with good Y as chicken, and let's say X is I'm not sure if I spelled that right, but let's say that good X is canned anchovies, which is a type of fish that's very salted. And let's just go ahead and assume, I'm not sure if this is confirmed with the data, but let's assume at least in this example, the good Y chicken is a normal good, and canned anchovies is an inferior good, meaning that there's a negative relationship between income and the demand for that good. All right. So what happens? We have good Y is chicken, normal good. Good X is canned anchovies, inferior good, and now income decreases. So see how we start at point B on this indifference curve. Income goes down, so the only thing that changes is the intercepts, which shift back this way in the same ratio. So see how the slope doesn't change, but this goes down and this goes down, so this goes down to the lower intercepts. Okay, and because good Y is inferior and good X is I'm sorry, good y is normal and good x is inferior, you got to show a new equilibrium where we're buying more of the inferior good with less income and less of the normal good, which is the case. So see how we go from B, Y1 and X1 to A, and so we're in fact consuming more anchovies with lower income because that's an inferior good, and we're consuming a bunch less chicken. So, and that's that's a likely example because number one, chicken's probably more expensive and probably more satisfying than canned anchovies, but canned anchovies are probably cheaper, and you could probably store them for multiple years, right? The chicken, well, unless you freeze it, doesn't last forever, but canned anchovies you can throw in your pantry, and you can probably eat them fine in a year from now. Okay, so you can see that it depends how you classify the goods. Here, both goods are normal. Income goes up. We buy more of both goods. Here, good Y is normal. Good X is inferior. Income goes down. So just go with the logic of inferior versus normal. And we buy at the new equilibrium less Y, more X. Okay. All right. Yeah. Everyone good? Okay. Okay. Next thing is we're going to break down uh, the effect of a change into, or the effect of a price change into two effects, which are very important. One effect is the substitution effect, and one effect is the income effect. So let's go ahead and look at what this means. All right, so let me define the effects here. So there's two effects. The substitution effect, and so they're very literal. You should take the effects very literal. Like substitution effect, you're going to substitute one good for the other. The income effect, you're going to have more or less relative income. Okay, so they're very literal. The substitution effect is going to be when there's a price change. This is going to be the movement along a given indifference curve that results from a change in the relative prices of goods holding everything else constant. And the income effect is going to be the movement from one indifference curve to another that results from a price change holding income and everything else constant. So when the price of one of the goods changes and nothing else, you're going to substitute for the cheaper good, okay? And you're also going to have more or less uh, purchasing power given the price going up or the price going down. All right, so this example, um, we're going to have a, an increase in the price of good X. All right, so all right, can someone give me a couple examples? Like, just give me any example for a good Y and a good X. It's not one of the ones I've already mentioned. So what's an example for? Let's look at it. Let's get an example of a good X and a good Y. Whatever you want. Just post it to the chat. All right. No ideas or no hot examples. So let me think of something. All right. So for this one, let's look at Okay, how about good X is car rentals and good Y is how about train tickets. So this consumer can decide between renting a car or taking the train. All right. So when the all right. So this is how many times they rent a car in a year or whatever, and this is how many times they take the train. All right. And we're starting at point A. Okay. So here's our budget line. All right. And what happens to the example here is an increase in the price of good X. All right. So that means, which is pretty much what happened recently, is the price of car rentals went up. Um, I'm not so much sure if the price of trains, like train travel, went up as well, but I know 100% that, at least recently, that the price of rental cars went up. If anyone here has tried to rent a car, and in some cases you can't even get one, depending on the location, but there's been a clear increase, at least temporarily, in the price of car rentals. So let's show that. All right. So the price of car rentals goes up, which means we're going to shift the budget line um, from here. All right. See how it like hits point G, and it's going to go to this one. So it's hard to see with all the lines going on, but this budget line, the flatter one, kinks in to this one. So we go from a budget line intercept on the x-axis of G to H. So the budget line shifts in because we can now buy less rental cars because they're now more expensive. Nothing else changed. The only thing that changed is the price of renting a car went up. So we go from G intercept to H. All right. Now we're going to get to point C, but you can see that there's two effects. So the movement from A to B on the initial indifference curve represents the fact that we're going to substitute um, some rental cars for some train tickets because the price of rental cars got more expensive and the price of train tickets didn't change. So see how we're going to substitute, we're going to go along the initial indifference curve and buy a few more train tickets now because those are now a little bit cheaper given the increase in price of rental cars. Okay, so going from A to B, substituting train tickets for rental cars is the substitution effect. Now, going from B to C represents the fact that the only thing that happened here is the price of one of the goods got more expensive. And if that's the case, our purchasing power or our real income went down because if we're buying uh, train tickets and rental cars and the price of one of those things got more expensive, then our relative income is lower. So we're worse off income wise because of the price increase and nothing else changing. So going from B to C represents the fact that we go to a lower indifference curve because our relative income is lower. Okay, so you can see that it's kind of hard to see with the all the shifts and arrows going on, but substituting along the initial indifference curve is the substitution effect. All right, and then dropping to a lower indifference curve is the income effect. All right, so A to B, substitution effect, B to C, income effect. Okay, and now let me see if I can find, maybe not. I want to show it with an income, I want to show it with the price of one of the goods going the other way, so getting cheaper. And I don't, all right, let me see if I can just focus. All right. So if we can see that, this is what I mean, this is the same thing, but this one shows, what is this? Okay, so hopefully we can see this graph, but what this shows is essentially a price decrease. So, and it even shows the little breakdown effect, okay? So let's just use these examples. This is good X, which is bread. And so can you see can everyone see this graph? All right, well, if you can't see it, let me know, and then I'll try to find a different picture. But if you can see it, I'm trying to illustrate the income and substitution effect with a price decrease, which is what this is. So we got eggs, good Y, and bread, good X. And we're starting at point one. All right, so here's our initial budget line and our initial indifference curve where we're at point one. We're consuming Q1 this much bread. Then what happens is the price of bread goes down. All right, if the price of bread goes down, that the uh, the bread intercept goes from B to C. All right, see how the price this curve kinks out because with the decrease in price for bread, we can now buy more bread. So this indifference curve kinks out from B and it now hits a point C. Okay, so this nicely shows that going from 1 to 2 along the initial indifference curve is a substitution effect because we're now substituting the cheaper bread. We're buying more of that and getting rid of some eggs because now, given the price drop, bread is now relatively cheaper. So substituting some of bread and giving up some eggs is the substitution effect because now bread is a little bit cheaper. So going from 1 to 2 is the substitution effect. Okay, then going to the higher indifference curve because if the only thing we're looking at is buying bread and eggs and our income is the same, if one of the goods got cheaper, we can buy more. We can buy more stuff because the price of one of the goods got cheaper, and that gives us a higher purchasing power, and our real income is higher. All right. So going from 2 to 3 represents the fact that we can buy more goods given the price drop, and we have more real income. And so going from 2 to 3 is the income effect. So see how this movement 1 to 2 substitution effect, this movement going to the higher indifference curve income effect, and the whole thing is the total effect. Okay, so you can kind of see it both ways for a price increase like we looked at for the rental cars and a price decrease like we looked at for bread. Okay, uh, yeah, makes sense. Okay, next thing is we can graphically derive an individual's demand curve by using this analysis. So this is a kind of a fun exercise. If you look here, so um, we can essentially show how you can use this indifference curve analysis with budget lines and change one of the prices to get to derive graphically a demand curve for that individual. Okay, so let me scroll down to the part I want to get to. All right, so this is what we're looking at here. So the first part is just showing what we talked about. So this is the top panel is the same analysis where we have good Y and good X, and then the price of good Y goes down. I'm sorry, the price of good X goes down. Okay, so let's make another example. And good Y is not changing, so let's just leave it. Let's just leave it at good Y. Let's say good X. What's something that's more? Let's say good X is all right. So this is something that has gone up, or that I know the price has gone up recently. Is wood or lumber. So let's say that X doesn't matter what good Y is because it's not going to change, or it's constant in this exercise. It's just let's just call it good Y. But let's say good X. Actually, that's not what I want to do because the price goes down. All right, different example. Um, good X. What's something that's gone down price? How about all right? How about this? Um, good X is now protective face mask. So as you're probably aware that maybe a year ago it was difficult to get face masks and they were pretty expensive relatively. But now, given the fact that um, there's so many out there, and given all the vaccines, a lot of requirements are dropping. It seems like you can get a face mask these days. I get them in the mail from just like for free, and so it seems like the price of buying a face mask has really gone down given the supply and the drop in demand. So it's pretty reasonable that I think at least recently the price of face masks has gone down. So good X is now protective face masks or face masks. Okay. So what happened? We're starting at point A, and there's a decrease in the price of good X, so there's a decrease in the price of face masks. So what happens is this price goes down, which means this whole number gets bigger. We can now buy more face masks, and this kinks out here from this intercept to this one, and we get when the price of good X goes down, we're going to move out to a higher indifference curve, okay, and we're going to buy uh, more X. All right, so the price of X went down, we buy more of it. Okay, we know that. We get to a higher indifference curve. And we can show that demand analysis down here. So this initial point, this graph down here is the price of good X on the y-axis and the quantity of good X on the x-axis. So this X and this X are the same. These are face masks, and this is the price of good X. So what you can see is that if we start here with this price, um, px0, all right, and this much X, so we're saying that these two levels of X are the same. And we know from the top analysis that if the price goes down, we buy more X, right? And we can just draw that point here. This is the higher X with the lower price. So what did we just determine? We determined that when the price of X goes down, we buy more of it. And that's essentially the law of demand, which if you could do a bunch of points, you'd plot that on average, when the price goes down, the consumer buys more of it. And when the price goes up, they buy less of it. And that just essentially derives the demand curve or the law of demand for, in this case, face masks, right? So all we're doing is kind of showing the link between indifference curves and demand, and basically just uh, essentially illustrating the law of demand. Okay, so I think those are so this, we're not doing this. There's a few things that we're not going to do in this class. Slide 8, slide 9, slide 10, and this we already did. So the rest of these slides, don't worry about because we're not going to do those in this class, but I do have some other exercises. So let's look at some examples that relate to chapter 4. Okay, so we're done with the PowerPoint, and again, slides 8, 9, 10, and 11. Ignore those. We're not doing that. Or yeah. Okay, so go ahead and open up under chapter 4, the chapter 4 document here. All right, so let's start with that. All right, so so we got some optional videos for indifference curves and substitution income effect. That's a nice one. Take a look at that if you get a chance. All right, and then this is something we're not going to cover, but uh, this one essentially derives the consumer equilibrium with calculus. If you want to look at that, it's kind of fun, but we're not going to do the extent of the calculus in this class. Okay, so here's some examples. Number one, a consumer has $400 to spend on goods Y and good X. The market prices of these two goods are PX, which is 10, and price of Y, which is 40. So part A, what is the market rate of substitution between goods X and good Y? So remember we defined the market rate of substitution as the ratio of the prices. So we know that the slope of the budget line, which is negative PX over PY, which is the ratio of the prices, and that represents what we define as the market rate of substitution between good X and good Y, meaning that if one of the prices goes up, that changes our if either of the prices changes, that changes the amounts we can buy because the price ratio has changed. Okay, but in this case, um, negative px over py is the general formula, and just plug in px is 10, py is 40, and that gives us a market rate of substitution of negative 1/4. All right, so that's the rate at which we can substitute on the market x for y. Okay, part B. Let's suppose income increases by $400. How does the $400 increase in income alter the market rate of substitution between goods X and good Y? So you should notice here that the market rate of substitution is only dependent on the prices, right? So if the price of good X changes and or the price of good Y changes, that obviously the market rate of substitution is going to change. But if just income changes, that's going to give us, if we get more income, we're going to buy more of each of the goods, but the rate of substitution is not going to change because these things didn't change. So the $400 increase in income doesn't alter the market rate of substitution. Okay, between goods X and Y, because the prices didn't change. However, you can probably realize that the budget line would shift to the right, and the individual would consume more X and more Y, but at that same 1-to-4 ratio, because the price of good X is 1/4 the price of good Y, or the price of good Y is 4 times that of X. But the definition of the market rate of substitution is just this, and those things didn't change, so that trade-off ratio doesn't change, but we'd shift out to the right. Okay. Part number 2. A consumer is in equilibrium at point A in the accompanying figure, and the price of good Y is 5. Okay, so here's the picture. This is the information we got. And given that, part A, what is the price of good Y? So we know that the general budget line equation is PXX plus PYY equals M. And if you solve that for Y, you get this. Okay, so look at the information you're given. Both intercepts. Okay, so remember, you know that if you solve for Y, you get your y-intercept is m over px. If you solve for, if you solve for y, you get your y-intercept is m over py, and you solve for x, you get your x-intercept is m over px. Okay, so we know that from before. All right, just solving for one variable when the other is 0. But you can see here that here's the initial equilibrium. This intercept is 20, and this intercept is also 20, which means the prices have to be the same, okay? So both intercepts are 20, all right, which would mean that if the price of good X is 5, the price of good Y also has to be 5, because we're, right, because the intercepts are the same, okay? So both intercepts are the same. Both prices got to be 5, because something divided by 5 has to give us 20. Okay. B, what is the consumer's income? So if one intercept is 20 and the other intercept is 20, and we know now that both the prices are 5, okay, then what divided by 5 is 20? Okay, obviously m divided by 5 is 20, so m is 100. 100 divided by 5. Or you can solve it for the other one for px as well, but either way, we have a budget of 100, because we know that 100 divided by 5 is 20, or 100 divided by 5 is 20. Okay, so we've determined by elimination, or just the information given, general formula, the prices are 5, and income is 100. Okay, at point A, how many units of good X does the consumer purchase? So just start with this general equation, plug in the prices of 5 and the income of 100, and then plug in um, 10 here, because it tells us. It tells us we buy how much Y, 10 of it, and we're trying to find out how much X we buy. So we have all the other information. We know the prices are 5, we know income's 100, and we know we buy 10Y. Now just solve for X. So we get 5X plus 50 equals 100. 5X take away 50 by both sides, we get 5X equals 50. Divide both sides by 5, and we get X is 10. So you can see that given the price ratios, we buy um, uh, 10 X's and 10 Y's. All right, then D. Suppose the budget line changes so that the consumer can achieve a new equilibrium at point B, which is this point. Okay, so that we moved to that higher indifference curve, and what can we conclude about that movement? What change in the economic environment led to this new equilibrium? And is the consumer better off or worse off as a result of the price change? So look at the graph here, and we know from what we've learned with moving the curves around that if we go from, so see, nothing changed in the price of good Y, or the price of good X. Okay, so that's the same. But it must be that the price of good Y got cheaper because this kinks up. So this intercept went from here to here, which must mean that this price got lower, which meant that this whole thing got bigger. So this change here from intercept of 20 to intercept of 40 can only mean that the price of good Y dropped or decreased. Okay, so we know the price of good Y went down. Okay, but we also see at point B, the new equilibrium at the higher indifference curve shows that the consumer bought more Y, got cheaper, but less X. See that? So A is this, B is this. We can see we bought at the new higher, better off equilibrium, more Y goes from 5 to 10 and less X. So we can deduce that the price of good Y decreased, okay, because the curve kinked out, and the consumer's better off. They're at a higher indifference curve because of the income effect. Also, good X and good Y are substitutes because after the change, the consumer bought less of the more expensive substitute good, X. Okay? All right, so a few more examples. Number 3, the consumer must divide 250 between the consumption of product X and product Y, and the relevant market prices are 5. The price of good X is 5, and the price of good Y is 10. So write out the equation for the consumer's budget line. So just start with the general one. Always start with this. PXX plus PYY equals M. Okay, we know that the price of good X is 5. Plug that in. We know the price of good Y is 10. Plug that in. And we know that our income M is 250. Okay, so the budget line with the prices is 5X plus 10Y equals 250. Okay, suppose the price of good X increases to 10. Write the equation for the consumer's budget line now. And how does this alter the market rate of substitution between goods X and good Y? So the new budget line, the only thing that changed is this went from 5 to 10. So we now have 10X plus 10Y equals 250. So the market rate of substitution is defined as negative PX over PY. And before, it was negative price of good X is 5. Price of good Y was 10. So negative 5/10 was negative 1/2. But with the change, you can do this. The price of X is now 10. So now we have negative 10 over 10, which is negative 1. So before, when the price of good X was cheaper, the rate of substitution was negative 1/2, and now it's just negative. It's just a 1-for-1 trade-off, which should be clear because the prices are exactly the same. Okay, so if the prices are the same, the rate of trade-off is the same. If the price of one of the goods is cheaper, then that one you can buy more of it relatively, given the rate of substitution. But if something changes, if either price changes, that's going to change your calculation for the market rate of substitution, which was the case here when good X got more expensive. All right, one more example. Good number 9. A consumer's budget line for two goods X and Y is 2X plus 4Y equals 500. Part A. Does the budget line change if the price of both goods double and the consumer's income also doubles? All right. So this one is a simple example, but it's got some pretty um, clear conclusions. So here's the budget line, right? So 2x plus 4y equals 500. Now let's double everything, okay? So we double our income, but that leads to, maybe by an increase in demand, of a doubling of the price of good y and a doubling of the price of good x. So, this is a nice mathematical example, but you can see if you get double your income, but that's paired with the fact that all the prices double, you're no better off because you can buy the same amount, you get more income, but the prices of the goods increased. So again, this is a simple example, but I think this has some clear implications as to why a lot of things are at least temporarily more expensive, because a lot of income was temporarily increased due to all the stimulus checks and uh, income that wasn't expected, I guess. And what that led to is a lot of the demand for mini goods um, going up, paired with the fact that a lot of those, like the inputs in the production process, was more expensive. And so even though a lot of consumers, not all, uh, had an increase in their relative income or total income, if the prices go up the same amount or more, it doesn't get you any better off because you're spending more with more income. So it's important to pay attention to what's happening to not only your real income, but also what you can buy with that income. Because if you get more income and the prices go up by a more or equal ratio, then you're worse off or the same point as before. But that's kind of the idea here. So if everything doubles, prices to income, you're left with the same amount. Oh, okay. And so no, the consumer budget line remains the same if all the prices and income double. So B, given the equation for the budget line, can you determine the prices of the two goods and the consumer's income? All right, this is easy because we know the how to interpret the budget line. So this is the price of good X, $2. This is the price of good Y, $4, and this is income. Just you should be able to look at the budget line and know what those numbers mean, which we do. So given the given budget line, you know the price of good X is 2, the price of good Y is 4, and income is 500. Okay. All right. So questions on these examples or concepts with the indifference curves and budget lines? Okay. All right. So next thing I want to do is get let's so that's the PowerPoint, the main concepts, and those are the examples. I want to go through or some of the at least some of the homework because I did some of it in Excel, and I want to show you kind of the way I did it, just in case you want to follow along with my template. So if you want to open up the homework for chapter 4, which is going to be due next week. So we'll essentially go through it because I want to make sure that everyone knows how to do it, because it's something that you can do either with Excel or with just graphing paper, whatever you prefer to do. But okay, so open up homework chapter 4 under chapter 4 in Blackboard. All right, so I'm gonna go through the example in Excel. Um, and then if you want, you can kind of use if you want to do it in Excel like I do. Uh, I mean, it's up to you for some of these problems. If it's easier just to do it like on graphing paper and draw it with a ruler, a pen and pencil, you can do it that way. I just found that over WebEx or Zoom, it's easier for me to show you using Excel, and so that's why I did it there. So you're welcome to do it in Excel like I do it, or if you just like doing it on a piece of paper, you can do it that way. All right. So let's go through this homework here. All right. So we won't solve it all, but I'll go through it. I'll go through all the technical stuff. So just one question, which is a really nice budget line example. So let's suppose you won $15 on a lotto ticket at the local 7-Eleven and decided to spend all the winnings on candy bars and bags of peanuts. So the price of candy bars is 75 cents and the price of peanuts is $1.50. Okay? So let me open up this. Okay, so this is what so I'm not going to post this, but this is or I'll post it after the homework is due, but this is how I did it in Excel. If you want to use this as an example, so what we're doing here is we're first um, setting up the budget line, and then we're going to have something change. So part A would be to construct a table showing the alternative combinations of the two products that are available. All right, so when you do these examples, just show the combinations of the whole numbers. Like, um, don't worry about like fractions of candy bars or like just assume that you have to buy the whole thing. So just what whole numbers. So don't worry about like half a candy bar or half a bag. Just whole numbers. So let's show a table showing all the combinations that the consumer could buy, given the prices and given their income. Okay, so make one of the goods X and make one of the goods Y. So I made good X candy, I made good Y peanuts, and we know that our income is 15. So just if you can visualize the budget line, you know that PXX plus PYY equals 15. So that means that um, 0.75X plus 1.5Y equals 15. So those are the prices. Okay, so you can see that I wrote a formula um, which I just see how it says equals 0.75A2 plus 0.1 or sorry plus 1.5 B2. So this is the price of good X, this is the price of good Y, and you can plug in different combinations that give you 15 because 15 is your income. So we could buy 20 X's and no Y's, that would give us 15. Or we could buy 18 X's, 18 candy bars, one bag of peanuts, that could also give us 15. So all of these combinations give us exactly 15. So these are the combinations: 16 and 2, uh, 14 and 3, 12 and 4, 10 and 5, 8 and 6, 6 and 7, 4, 8, 2 and 9, or 0 and 10. So what I'm saying is that given the prices and the income, the consumer could buy all candy bars and buy 20 of them. They could buy all peanuts and buy 10 bags, or they can buy some combination in between. But all these points are possible given the prices and the income, right? So see how here's the initial graph where I just graphed all those points where this is peanuts, good Y, and this is candy, good X. Okay, so when you do your homework, you can do exactly what I did in Excel and make a little graph, or you can just kind of set this up in graphing paper and do this graph manually. But I want you to put the axes and the points and kind of show. Well, I guess we haven't got to the graph yet, but this is the part A, where he's showing the combinations of which you can exhaust your income by buying the different combinations of the goods. Okay, then part B is plot the data in your table as a budget line. Okay, so I did that here. So either put your data in Excel and make a graph, or just draw your graph, just plot the points on graphing paper and just draw it manually. But either way, you got to produce a graph. Okay, so here's the graph where these are all the combinations of peanuts and candy this consumer could buy, given the prices and given the income of $15. Okay, next question is what is the slope of the budget line? Okay, so the slope of the budget line is essentially the the negative ratio of the prices. Okay, so it doesn't really matter if you go x over y or y over x. Either one is the slope depending on what you're looking at, but I usually do um, x over y. Okay, so remember the what was the market rate of substitution or whatever that was called? You can use that, which is negative px over py. So there's that. Just plug in px, which is negative. Plug in px, which is 0.5. Plug in py, which is 1.5, and the ratio of the prices is the slope of the curve. So negative 0.75 divided by 0.15, 0.75 divided by 1.5 would come out to negative 0.5 or negative 1 half. So the slope of this curve is dependent or is determined exactly by the price ratio, and 75 cents divided by $1.50 is negative 1 half. All right, what is the opportunity cost of one more candy bar and then one more bag of peanuts? So if the consumer wants to get one more candy bar, what will it cost them in terms of giving up peanuts and vice versa? Okay, and so you can see that this trade-off is the same, but every time the consumer gets two candy bars, they give up a bag of peanuts, plus two minus one. So to gain two candy bars, you got to give up a bag of peanuts. Um, and so essentially, every time you want to gain a candy bar, you got to give up half a bag of peanuts. Okay, and then conversely, every time the consumer gains a bag of peanuts, they give up two candy bars. Okay, so you can see how the rate is like reciprocal. So the opportunity cost of a candy bar, just looking at the chart, is half a bag of peanuts. That's what they give up. And the opportunity cost of a bag of peanuts is two candy bars, right? And do these opportunity costs rise, fall, or remain constant as each additional unit of the product is purchased? So you can see that given the prices in the budget, that this trade-off, plus two minus one or plus one minus two, is always the same, right? So if you want to gain more uh, if you want to gain more peanuts, the number of candy bars you give up at any point is always the same. And if you want to buy more candy, the number of peanuts you have to give up is always the same. So this ratio is the same because it's a constant constant slope budget line. So this rate of trade-off is always the same for this consumer. All right, and then part C, we're going to essentially show um, a change in income. So let's suppose for part C, we had won $30, not 15. So that's a bump of income of 15. So income goes from 15 to 30. Now let's show the $30 budget line in your diagram. And why would this budget line be preferable to the old one? So all we did here is, given the example in the word problem, the extra lotto money is essentially an increase in budget, or an increase in M, or an increase in income, whatever you want to call it. Okay, so the prices are the same, but income went from 15 to 30. So the only thing that changed on our budget line was that it's now PXX plus PYY equals 30, not 15. So now we can show all the combinations here in which, with the doubling of your income, you can buy essentially double the amount of goods at each point. So here's all the combinations uh, that give us $30, that exhaust the $30 income. So it essentially, just see how the new budget line is going to shift out by plus 10 on the axes. So this intercept goes from 10 to 20, and this intercept doubles from 20 to 40. All right, so to spend our new $30 with the same prices on only candy bars, which cost 75 cents, and only peanuts, which cost $1.50, we can buy all candy, and that would give us 40 candy bars. We could buy 30 candy bars and 2 bags of peanuts. We could buy 32 candy bars and 4 bags of peanuts. For all these combinations, up to the fact where we buy only peanuts, which would mean we could buy 20 bags of peanuts and no candy bars. And if you plot these points, which are essentially your new budget line and all the combinations which you could buy candy bar and peanuts with the newer income of 30, you can either plot these points manually or have Excel draw a graph. See how I just plotted the points? These are all the possible points now where we can buy different combinations of peanuts and candy bars. So essentially the budget line shifted out. Okay, so if you're doing it by hand, you can either do the two separate graphs here, or you could just show kind of the budget line shifts out like this way, and the new intercept is just, beyond here. So the budget line shifted out, and this is the budget line with the extra income. All right, so why would this budget line be preferable to the old one? Obviously because you have more income, the prices didn't change, and you can get to a higher level of satisfaction, buy more of both goods with the same income. Yeah. Okay, so when you do this homework, um, you can either do it in Excel and kind of take a screen cap or copy and paste your graphs, or you can do the graphs on like graphing paper and take a screen cap or take a picture and do that. But um, okay, so make sure you know how to do the uh, set up the budget line and make a chart of all the possible combinations that the consumer can buy, and know how to do the analysis if income goes up or down. And then later, not in this example, we'll do it when one of the prices goes up or down as well. Okay, so when you turn this in, you don't if you're doing it in Excel, you don't have to turn in the Excel file. You can just kind of take a screen cap of your graphs or copy and paste them. You can turn it in if you want, but um, you don't have to. Okay, so questions on this homework assignment or any of the stuff I did in Excel, if you're doing it that way, any questions on what I want you to do for this assignment? Okay, so I think we'll finish a little bit early today because I scheduled less for today and I went over the first couple meetings. So on average, we've gone about 2 hours each time, or a little bit more, I guess. But that's that's what I wanted to cover for today. So we did the indifference curve, the budget line analysis with the consumer equilibrium. We did the changes in the substitution income effects and how you can derive the demand curve, and then how you can kind of do the analysis graphically and et cetera. So, okay, so again, just a reminder, the homework for chapter 3 and the elasticity homework are both due today, so make sure you get those posted here by the end of this evening. And then someone's already done the chapter 4 homework, but the chapter 4 homework is due next week. So these two, chapter 3 elasticity due today. This is due next Monday, just like the syllabus says. Okay, and then next week, what I want to cover is today was a relatively short thing because we just did one chapter. Uh, Next week, I expect class to be at least 2 hours, maybe a little more because I want to cover the chapter 5 and I want to do a little review session for the midterm. So we'll do chapter 5 next week. If you're reading along, you can read that chapter. And we're going to do some practice problems for the take-home midterm because I want to make sure that everyone is prepared for that. So we got a couple things to do next week, so it'll be a little bit longer than today's meeting, but I'll see what. Yeah, okay. But then we have 2 weeks off. So uh, next week, chapter 4 homework is due. We'll cover chapter 5 if you want to read that beforehand, and we'll do the midterm review. I'll show you where. Well, the midterm's already posted, but I'll make sure that you know what to do for that. And then the chapter 5 homework in the midterm will be due 2 weeks on July 12th, and then again we don't have a meeting on July 5th because that's an observed holiday with Laverne. So yeah. Uh, okay, so if I think we'll finish a little bit early if that's okay with everyone here. That's what I had planned, and have a good rest of your week. Thanks for joining, and I will see you in a week.